G'day everybody and welcome back to the channel. I've got something to show you. See if I can find the other bit. Yep, there it is. I was cutting out the front panel for this supply and my nibbling tool broke, so I'm going to have to take a bike ride to J-Car tomorrow and buy another one. Just trying to show you how it goes so you can see what happened. So it normally goes like that. Whoops. And this bit broke off. So I can't cut. That's how much of the front panel I had to go. I shit you not. I just had to get up to about the A. I'll show you. Alright. Yeah. Anyway, not to worry, we're still going to continue building this. We've got to cut all the wires to length, install the board, wire it up, and add the stuff to the front panel, which I'm just going to try and solder on there. As is, I can't really be bothered making a board up for it. This will get installed tomorrow. I'll just do a quick little update video. I mean, there's nothing I can really do. I might have a little go at, you know what, I'll try and cut it out with the Dremel now quickly, but this is really, it's very tough steel. It's like in between mild steel and high tensile steel. It's certainly not just mild steel. I know what mild steel is, I cut plenty of it. This is a little bit harder, so I don't know. Seems everything back in the day was just made better than these days. I've noticed that a bit actually with steel. Older steel just seemed to be tougher. Anyway, I'll see if I can cut the rest of this window out. If I can't do it with the Dremel, you know, I'm just going to keep exploding blades everywhere and risk hurting myself. We'll just proceed as it is. But that's what's happening. We're putting this together finally. Alright, so I decided to just go for it in terms of hooking up the components. I'm not going to even try cutting this out with the Dremel. I know what's going to happen. I'm just going to explode cut-off wheels everywhere. I'll just get a couple of pairs of those snips tomorrow. They're not really designed for cutting this out. I am abusing them, but I've used them for years and abused them for years, and they've lasted for, I don't know, a couple of years, and I got almost all the way around here without them breaking. So I'm sure if I buy at least 2 pairs, I'll at least get this done and still have a pair. Yeah, I really need to buy some tools for this sort of thing. What I'm going to do is I'm going to just solder the components straight to the back. I've looped the capacitor around and sort of got the diode in there too, the anti-parallel diode. I've got some freeze spray on hand, so I can spray it. If I've got my soldering iron turned up to 370 actually, I'm going to turn up to 380. And I've got my freeze spray ready too, so let's just try and be quick. This is not making me comfortable. I guess these are only cheap jacks, and I do have a lot of them. Alright, well I got that. Yeah, well it didn't get loose, so I didn't melt the plastic. Okay, that's actually quite doable. Got a drip of solder down here. Alright, well that's what we're doing. If it works, it works. I'm happy with that. No, I'm not spraying the solder itself. I'm spraying the plastic. I mean, if it did crack, I'd fix it anyway. Alright, well that's got that nicely in there. Just going to put a little bit more solder on the top of this one. Yeah. And for this diode, good enough. It was already good enough in the first place, to tell you the truth, but I just want to make sure. Alright. So that's that in there. Now the beauty of having the diode, the reason I did this is because everything else can go off the diode now. And then I don't have to worry about melting the connectors. I'll put my sense wires here, but I'll put everything else up here. Just trying to work out the best place to fit this in. I'll fit it somewhere. Maybe not there. Oh, its legs have been bent to the side. Okay. It was installed on a board sideways. That gives me more legs. I could just put it there, but I think I'll do that. Yeah, I'm happy with that. I'm just forming the legs up so it can sort of hook around the diode. Yeah, that's really good. Cool. I'll do it about there. That way I've got access to the top still to add my wires. I'll put it the other way so we can see the resistance on it. It's always good to leave values where they're visible, so if you've got to come back and work on something in the future, you don't have to pull everything apart just to read values. Not that anyone gives a crap about that with today's manufacturing standards, but I do. It would help if I could see what I was doing. Oh, that's actually soldered in. Okay, that's our resistor and diode. Now, these two guys, I'm just gonna twist the two legs that I want together and just solder them and cut them short. Like that. And now I've got to find a way to get this across the output terminals too. wouldn't mind having them right across the resistor there. I could make that happen. Yeah, we can make that happen. Beautiful. Oh my God. I'm so sorry. I'm sorry, I really had no clue that that wasn't on camera. I don't know how long that's been like that. God, I hope I just moved the unit back or something and dragged it off camera and it was on camera in the first place. If not, my apologies. Okay, that's that in. Now I don't need to worry about it going anywhere because it literally can't go anywhere. I'll just fold that forwards a little bit and I'll solder a little earth wire from that goes over to here and then back to this. Again, if this was a super low noise supply like my big one that I'm building, I would not what's the word? I would not run both off the same earth wire. I'd run star grounds all the way back, but in this situation it's not really important. I want to leave a little bit of slack in there so that when the back opens, it is screwed down to the bottom of the back so it doesn't have to move too much. But I want a little bit of slack in there. 1 minute. Sorry, I still got a cold. Okay, that's nicely wrapped. Yeah, none of those came loose at all, so that's great. And that's good too. Just got a bit of slack. Alright. I did say I was going to try and reuse as much of the original bits and pieces as I could. Let's even reuse bits of wire. Turn that back down to 370. Wait, what? That was odd. I'll just leave them up like that then. The beauty of this old school wire is it's so bloody solid, nothing can go anywhere. Like, it's, yeah, I like that. Alright, so I'm going to bring my sense wires in at the bottom and my power just on the top of the diode like that. That'll do for that. This just goes directly across the capacitor. Now, what wires have I got on the bottom of this? The base needs to be wired up first. The base is the yellow wire. Okay. Just got to work out. I've got a couple of wires that are going to come in from the bottom, and I just want to work out. I think I'll go down the side like that and come up. That's our base. Bases. That goes, that's a bit too tight. That goes off to the series pass bases. We also have our negative in. That's this grey wire. So that's going to be on the other side, so that'll be a bit shorter. Jesus. Fuck. Come on. These wire strippers the last couple of weeks have just started acting weird. Like sometimes they're just chewing wire up, other times I just loosen them up and they've gone tighter. I don't get it. Yeah, I can make that work, I guess. Bloody made a mess of that. Yes, that was a piece of cotton restraint inside that wire. I've not come across that before in a single piece of wire. This tinned wire really doesn't like to take solder. It's bloody weird. So that's everything in the bottom. Then we've got collector. That's sort of down the bottom. Oops. Collector. That's this one. Come on. This one wire is going to be an absolute, you know what, to get in. Jeez. I want to go under the capacitor and in there, but I've got to hold it somehow and solder it too. That's just bonkers. Well, I got it. This wire takes so long to suck up solder. I don't like it. Collector. Alright, we want positive. Everything else can go from the top of the capacitor. The only thing that's got to sneak up the bottom's the power for the LED. That's fine. Alright. Oh, the LED wires can't fit under the circuit board. Okay. Where am I going to put them? That's a bit of a problem. Oh, they're still under the board. There we go. Oh, now they're under bloody transistor. I really don't want to snap this LED. I think I'll just leave that. Yeah, that'll do. Oh, they just reach. That just works for me. Cool. I'm not going to deny my circuit board just barely fits in here. Like I said, I did make it a little bit bigger than the original one. I don't like those LED wires crimped in the case like that. I'm going to drill a hole through the board and pass them through the board just there. I'll be back in a second. I'll just put a hole, say, there. Yeah, that's much better. I am much happy with that. Yeah. Alright. Now, I don't know how I'm going to tie this capacitor down without a bracket. I only have one cable tie left. So, yeah. Don't know how that's going to work out. You know what? I don't think I'm going to use a cable tie. I think I'm just going to get a bit of copper wire and run it under that bracket and under that bracket and just do twisty at the top. At least it'll be locked down. It won't be able to move, you know, because I've only got one cable tie. I can't exactly loop one cable tie around two brackets. That's just not possible. Yeah. Alright, moving on. So this is our emitter. This goes to our positive terminal. That will do. Just going to pre-tin up this diode leg because it doesn't like taking solder for some reason. Alright. Neither does this wire. I think I'm just going to flow it into that blob. something like that. Yeah, screw it. Let's get a massive ass blob of solder and just flow that in. Let it set, and then I'll just put another blob on top of it for good measure. Try and catch what's coming off the bottom. Yep. I'm just going to try and half flow another blob. By half flow I mean like that. So it's melted its way through the first bit of solder, but it hasn't gone all the way down to the bottom and dripped off, so to speak. I hope that makes sense. Yeah, that'll do for me. Alright. Positive for this goes there, negative goes there, and the other wires are going to go there. So yeah, we can do everything like this. Cool. This wire is the AC, this goes here too. That can be nice and short. Yeah, about that. If anyone knows what they used to tin wire with, why it's so hard to get it to take solder, although you know what, I actually find that sometimes even with brand new wire that I buy from J-Car that's pre-tinned. Same with this tinned copper wire. You guys have seen me using it. I have my soldering iron in between 350 to 380 degrees and it still doesn't want to take solder. If anyone knows why, is it just crappier solder? Is it got a different alloy mixture? I'm curious. Because that old 80s wire from inside here obviously can't be lead free. So it's not lead free. I'm not saying that the stuff I'm buying new isn't lead free. I'm just saying that that can't be what's going on with this old 80s wire. Okay, I've just spotted something that I'm a little bit concerned about. I'm going to put a spacer in here because I don't like the fact that I've got the tracks going right to the edge of the board. It could almost touch that front panel. It can't really, but I'll see when I've got it all together and I've worked out how I'm going to mount that down, if it's able to go near it or not. If it is, we'll do something about that. Alright, so now I need a thick bit of wire, which I've got here, to go from negative here, negative out, over to the negative here. I've got to go clean my cat's dirt boxes so I can smell cat poo and it doesn't smell nice, so I'll be back. Right, back on with this. I've just noticed something. It's not the end of the world. When I designed the board for this, I measured it with it sitting straight. I don't know why it's on a bit of an angle in with the capacitor sitting on its bracket. I can always put, a little bit of foam or something under the capacitor and then clamp it down so it sits flat like that. That's fine. The way I measured, where I cut this box here for the panel meter, I'll just show you. If we look, there's my camera. If we look directly in line and move that back, you see the transistors. It's kind of hard to line it up, but you have to take my word for it. The transistor's not in the way of the panel meter. But, and neither are those capacitors. If you look in the top, they're actually higher than the meter. But the problem is, when I added these diodes and this resistor, they're standing up higher. They are in the way. Yeah, I might be good with my electronics, but I always make a mess of layout. I must improve my layout skills. Seriously, and I need to get some more tools that will help with that sort of thing too. I'm just wondering what to do about this. The resistor actually will fit. Yeah, the resistor will fit. I wonder if I can... You know what? I can push these diodes down and the whole thing will fit. It's all good. I was going to say, if I can't sort of fold it in a bit, I can always put them on the back of the board, but I don't want to do that. Yeah, that works. Beautiful. Oh, my board wasn't all the way back. Oh, now I've got plenty of space. Yeah. I don't know why the board wants to go in on that angle like that. Ah, I know what I've done. It's where I've put the holes for the capacitor. They're like a millimeter too high. They needed to be a bit lower. That's alright, I can just pack the capacitor up this end. It's not the best thing in the world, but it's all good. The other thing I think I just realised, I'm not sure, it looks like it, these couple of wires that are soldered here, I probably should have left more slack on them. But to be honest with you, in my mind, I'm thinking use thick wires, make them short as possible, less voltage drop, right? I wasn't really thinking about getting the back off, but it's alright. I don't see the back having to come off, I don't think I'm going to have problems with it. It's a pretty solid sort of device. I'm happy with that. Alright. I just need to wire up the pot, the LED and the 2 cents wires. I'll do the LED first just because it's here and it's easy to get to. I wonder if it's holding that in place. That's bewildering. What? Oh, I'm not going to complain, it's helping me right now. You know, I've had this power supply sitting on the shelf for years. It's finally going to get some use. That's our LED. Right, pot and feedback and case. Well, I guess I need to get those snips so I can put the panel meter in, and I need to put something under here and tie it down, but other than that, we're getting there. I'll just put the screw in for this transistor too. Now the board's not running around everywhere. I'm not really worried about it moving around and ripping the legs off. What the hell, that was perfectly lined up with the hole. Oh, it is lined up with the hole. It's just turning so smooth that I literally thought it was not going down. Oh, you know what I bloody forgot to put in there? Thermal paste between this aluminium block and the case. Definitely want that in there. Okay, I can get to it. Just trying to make sure it's all got good coverage. It's a bit hard to get in here like this, but I'm getting it. All right, got it. And I've lost the lid. God, I can't wait to rebuild my lab. It's just too small in here. Oh, I got it. I'm happy I can see the thermal paste oozing out every side. Beautiful. What's up, little man? Little man always comes in here and complains. Alright, I'll go get some wires and I'll strip them up in preparation, because all we've got to do is add our pot, 3 wires to the pot, to the board here, and our 2 cents lines back to the board here. I'll go make those wires up off camera know what, that transistor could be in the way a little bit. Hey, now I don't even need to move the board back. Yeah, that's cool. I'm happy with that. If I leave that capacitor there and that tilted back and all that pushed down a bit, the panel meter can just slide straight in. And I'm not... No, I am going to put something under here because now it's sitting off of the legs off that transistor. I did muck up my marking for this capacitor's holes. Yeah. Alright. I've got just the thing to fix that. So I'll go get that and some wire. Alright, so I've come up with a solution for securing this. I know this is kind of dodgy, but look, I screwed up the board. What was I going to do? Remake the whole board because I drilled the holes a millimeter too high? I can't do that. So I just cut up some toilet paper roll, paper towel roll, can't remember, I think it was a paper towel roll. I just sort of cut two portions off of the end of it and then stuffed one inside the other and curved it up into a U, and then put that U underneath the capacitor's bracket with most of it around this side, so it's held up and back. And I actually found the spot to get the cable tie in. I don't know if you can see, like you see how there's this chassis mounted in a chassis, or sorry, chassis in the case. Well, I say silly things sometimes, eh? Well, you can get the cable tie underneath the chassis, in between the chassis and the bottom of the case, and then back up. There is a gap down there, see? So that's in solid now, that's not going nowhere. And the front panel, I gave it a slight bend out. It's pretty well straight, honestly. If anything, it was, yeah, probably a little bit pushed in, but with the board held over there, there's a nice gap down the side of that now. I know that looks like it's on the transformer, but actually, no. There's a gap all down here. It sits in front of it. So that's that problem sorted. Now, to wire up the pot and the sense terminals, I've got a box of wire. I've got all those boxes behind me with all different bits of wire, and then a little box of just random bits of wire from projects. More wire. There's wire everywhere in here, but anyway, I've got this bit. It's 3 wires twisted up together, so I use that for the pot. Still turned on. And for the sensing, I'll just pause the video whilst I choose a couple of bits of wire out this box. Alright, I've got all my wire made up. Now, I just wanted to talk about something that I remembered, which is really interesting, because we actually discovered the reason for this problem in, not this video, but one of the videos in this series. And the problem was, before I had done this, and before it was sitting on the shelf in here for a couple of years, I was using it to power, just to test power car amps that I was fixing. I've got those big ass power supplies, my switching power supply that I've modified, and that huge ass transformer that's down the bottom that I've shown in other videos in here, that can produce, upwards of 250, 500 amps, depending on which supply, at 14.8 volt, 15 volts, 16 volts, something like that. Those are what I use for big amps, but just for testing, I used to use this. And what happened was, eventually I started noticing that it was running really hot, and I mean the transformer, the heatsink, the whole thing was just a hot box. And I noticed that, I think the last 2 times I used it, didn't have it powered on for very long. Noticed it was hot, obviously turned it off straight away, because I could smell the transformer, and I could feel the heat was, too much. It wasn't right. And then I put it away, and because I was testing an amp, I just put it down to me being an idiot because I'm a bit of a bass head, so I think I had like a little subwoofer hooked up or something and some speakers running off another amp, and I turned it up a little bit, and I shouldn't have turned it up running off this. So I thought, both times that it heated up that it was just me because I had car amps on it, and I was turning them up a little bit with a load on them on what's essentially just a little test power supply that's only good for about 8 amps. So I just put it down to that. Well, I don't know if anyone remembers, but one of the transistors on here was leaking through the mica to the heatsink, because when I tested one of the transistors, the left one, it tested as 2 diode junctions. But when I took the transistor out and changed the mica insulator for a brand new one and put new thermal grease in and put the transistor back in, it tested as a transistor. So that was the old transistors, not the one that's in there now, but it still tested as a transistor afterwards. So that explains why it was running hot. It had biased itself on. It had some sort of fairly low resistance short. So yeah, that's lucky that I was only using it to test stuff and noticed it and turned it off. Otherwise this would have gotten smoked, and probably the transistors too, but the transformer's a little bit more of a worry than the transistors, because let's face it, if the transformer goes, you've got to get another one or rewind it, which is an absolute what. And if the transistors go, you've just got to change them. So got lucky. I forgot my drink. I'll be back in a sec. Alright, that's better. So yeah, as I was saying, that was a lucky save. Anyway, I'm going to tin these wires up and we'll get them between the terminals and the sense pads. Is that on camera? I am aware that some of the segments in this video I locked the image and some I didn't. I've still got to get in the habit of that. My apologies. I mean that seriously. You got to understand, one, I'm new to this, but that's not my excuse. My honest excuse is the fact that I come in and out of here and shoot multiple scenes and then splice them together, and just to be honest, sometimes I walk back in and hit record and I just forget to lock the image. It just happens. I've just got to get used to it. But I'm not going to lie, it annoys me when I watch it back and I see it jumping, so that's why I say sorry, because I am genuinely sorry for that. Alright. Now these sense wires, you're not going to be able to see me solder the positive one because I need the power supply tipped up this way. I need to get these as close to the terminals as I can because this is the sense. See, the other wires that I've soldered on to the diode and that bring the power into the terminals, yes, that's not directly on the terminal, but any volts drop, millivolts are lost across connections and bits of wire and stuff will be made up for via sensing, as long as the sensing's done after the volt loss, the volt drop, if that makes sense. Get on there. Got it. That was awkward. I just don't want to melt the plastic on those banana jacks. That's on there. So that's our positive sense. Yeah, it's going to be hard to take the back off this thing because all the wires are fairly tight, but I was going for low resistance and low voltage drop. And you got to admit, this thing has got really nice low noise and good regulation considering what it is. I'm a bit of a nut like that. All right. So this is our negative, is it? Can't tell what's going on here. Yes, our positive sense is this end. I'm actually going to make these wires a bit shorter. The thing with the sense lines in this design is they actually have current on them too. Not a lot, but enough that you can get, you know, a couple millivolts drop on the sense lines. That will translate to a few millivolts of error on the output, because the feedback circuit's got a Zener in it and a couple of Zeners in it, and basically power being dissipated in that circuit path. So because there's current flowing, obviously any resistance the current flows across is going to translate into voltage. So that's why with something like this it's important to use thick wires and short runs. I think what I'll do is I'll just solder this wire to the pad where it is, and then I'll push it up and reflow it a bit higher. Like that. That's better. Cool. Neat. Alright. Now for our positive sense. Oh, you know what, I probably should have soldered the pot first. I'm going to at least put these on the pot before I do any more. Otherwise it's going to be quite tricky. It's already going to be quite tricky. I didn't think that through. Bummer. The things I do. You know what? I'm just going to take the pot out. It's going to save a lot of messing around. Bummer. Get in place, come on. That will do. Alright. That was a lot easier than trying to solder it in here, especially with this wire already put in. Why am I missing a washer? Oh no, it's on the pot. I just want to see where the pointer goes. I wasn't happy with the orientation of this before. Alright, so I actually want it like that. I'll show you what I mean afterwards. I'll turn it around when I put the knob on it and I'll show you. Before the pointer was stopping and starting in, let's just say, odd spots. So now it's actually makes sense, like max, min. Alright, I'll put this other sense line in first because that goes down the bottom. I'm not kidding, the shorter they are, the better. You'd be quite surprised at the performance you can get out some rudimentary circuitry if you actually know what you're doing, as I've proven with this. Yeah, I'm happy with that. Alright, now I've got to work out where the pot goes to because that changed. Obviously our orange wire, which is the wiper, still goes here, but where does the rest of it go is a good question. Okay. Okay, so the green is going to go here where the positive is, in that hole there. The orange, which is the wiper, will go here to the base, and the blue is going to go to that hole just there next to the base. So there for each end of the track, and the wiper there. All right. I know this is not a high enough impedance circuit to be bothering twisting wires or anything. I got this out of the box like that. I just chose it because it had 3 wires and they were already neatly twisted up. Certainly isn't going to hurt. That's better. So I've got to get a couple of nibbler tools, cable ties. Should get some new wire strippers too. Probably won't have enough to get wire strippers as well. We'll see. You know, I'm going to tin the wires first. I know some people don't, but each their own. I just like all my soldered connections to be nice and strong, shiny, you know. You know you've got a good connection when it's nice and shiny. That's why I don't understand how some people have trouble soldering. It's so simple. And I'm not talking about any of my viewers. I'm sure you guys know how to solder. I'm talking about all these like Indian electronics channels and stuff you see. And they just like blob it around. They don't even understand what the word flow means. It just amazes me. Alright, so the green, we want that to go to the positive because that's, let me think about this. Sorry, no. We want the blue to go to positive. Incidentally, having short, thicker wires on the pot is important too because that's also in the same feedback path as the sense wires. Actually, no, that doesn't make as much of a difference. In this circuit, but the sense wires really do. Let me think about that. Yeah, no, it's your sense wires that's going to matter because they've got current on them. Last but not least is green. Alright, now just so I can get the video finished, because this is literally finished now, what I'm going to do is I'm just going to hook the panel meter up, just run some wires out the front, and we're just going to give it a quick test run, because otherwise I've got to wait till tomorrow just to upload the video when it's finished. It's just, I've got to finish cutting a square and go pop, you know. So what I was going to try and do to power it was power it straight from here. I want to see how much noise this adds to the circuit too, because as we know, these things add noise. What I'm going to do, if I can get that to reach, yeah, I'll put the sense wire in the output. And I'll wire the negative up to the front too. And we'll take this over to the scope and we'll see what how I'll just do it on video instead of trying to explain it. Hold on. God, I hope everyone had a good laugh. I turned it on. I'll just show you from here. I turned it on and I got this. 22 volts. And I thought, what the hell? I know I've done everything right. And then I looked in here. I put the bloody negative sense on the ground terminal, not the negative terminal. Silly me. Trying to sense the earth. That's not going to help. I'll just move that. I'll pause the video whilst I do this. Hold on, let me just get this wire off, because I've already started. Then I'll hit pause so I don't waste your time watching me resolder the same wire. Alright, that's back in and I'm out of freeze spray. Well, I do have a new can ready to go, but now my stock shelf is empty. Alright, so now the sense wire is actually going not to the earth terminal, to the negative terminal. Let's do that again. We should get 18 this time. You gotta be kidding me. After all that, I still wired the ends of the pot the wrong way. Bloody hell. How on earth did I manage to do that? I swear I even checked it. Alright, I'll correct that and then I'll come back. Okay, I've reversed the track on the pot and I've routed those wires underneath here so when I put the panel in tomorrow they won't be in the way too. Let's give it another try. We should be in the right direction now. Now the meter's upside down. That's a lot better. Alright. I am going to put this here. Put this here. Actually. There we go. Let me just see if I can get better focus. That seems to be about as good of focus as I can get. Alright, now I've only got just a normal scope probe for this. I'll just put it across the diode. Just let the waveform settle down. Oh, I don't feel like waiting. Alright, let's unplug this panometer. Wait, really? Really? You know what, I can't tell if I'm just picking up so much extra noise. This is, now you see why I designed those special probes. Do you see the difference trying to do it with this? And yeah, I can tip and barrel it. Well, I won't be able to tip and barrel it, but I'll probably be able to tip and spring it. See, that's tip and spring, and you see how much noisier that is still compared to my probe. You'll be quite surprised what you pick up. I think I'm just going to hook the negative wire to the negative terminal 2 for this one. It seems I don't know, this circuit seems to be behaving differently and rejecting the noise on the negative terminal. I'm going to have a look into that. The only difference in terms of the emitter end of the comparator transistor in this design to my design, which has super accurate references and floating supplies and super accurate supplies and everything, but the comparator transistor doesn't have a Zener diode because I've got super accurate references, so there's no Zener diode in its emitter path. And I noticed the noise ends up back in there, so I'm going to have a look into that and see if I can improve on that. It's good when you notice things like that when you're building different things, because sometimes one thing sheds light on something else. Well, I'm going to call that a win. I can't remember what the actual measurement was, but we did take the measurement. You can watch the previous video called compensation if you want. In that video, I measured across the output capacitor, which is what's soldered to these terminals, and you know, it was like 150 microvolts RMS and maybe a millivolt peak to peak, or 1.2 or something, I can't remember, but it's nice and quiet. The other thing I want to talk about quickly before I end this video, just in case anyone's trying to replicate this, I mean, by all means go replicate it. It's a great design, it's rock solid, it won't break, it won't let you down. Doesn't have current limiting, but don't take it one step further and take the limit Zener out and the emitter Zener and replace the emitter Zener for adjustable reference and give it 100% feedback, meaning that you can make it go to 0 volts or 0.6 with this circuit topology, because even what this goes down to, what, 5.8, with a load on that, those transistors are going to be dissipating quite a bit of power. If you turn this all the way down to a volt or half a volt or something like that and tried to put 5, 6, 7 amps on it, the amount of power these transistors would have to dissipate, this heatsink could not get rid of it, you know. You don't have multiple taps on this transformer, so there's no tap changing. You've just got the one rail. So yeah, we're actually lucky it's only an 18 volt transformer. Yeah, so it actually works out quite well. 6 volts to 5.8 to 18. And you know, I'm actually quite happy to have it. Look, I wanted to be able to have it go just, you know, about a volt or so below 6.3, so that if I'm, say, powering up, trying to use it just as a filament supply for some old tube equipment or whatever, you know, I can turn it up to 6.3. If I wanted to underrun the filament for certain reasons, you know, I could still do that. If I, you know, it would be nice to have, you know, 5 volts, but I'd have to put an even smaller value Zener in there. And when you go up to the top end of the voltage, because the reference value would be like 3.3, 3.9 volt Zener, the feedback voltage would be like this compared to the small reference, and the comparator would be doing a worse job of comparing the two, and you'd get worse accuracy on your output. So that's the thing about designing stuff. Even something simple like this, there's a lot of different compromises that you've got to consider for what you want to get out of it, basically. And my goal with this was basically to squeeze the most I could get out of it for what it was. You saw what it was. It was just a 13.8 volt power supply, and I can tell you now it had noise and ripple on it. It was not the cleanest supply I've ever had. It's bloody quiet now. It's adjustable. You know, it's got ground. It's got a power switch, a display. I've given it way more usability than what it had. So that's a win for me. That was the whole goal of it, was to turn it into something useful instead of just a bit of junk on the shelf collecting dust, basically. And I think I've done that. So I'm going to upload this video because, in all honesty, all I've got to do is solder literally the wires where they're attached now, the positive to the positive of the cap, sense to this but on the back of it, and negative sense to the back of the negative, and finish cutting that out, pop that in there. I'm going to put a label over the what's left of the Motorola, and what I'm going to put on that is you know, I'll work out, I'll psych test it and see what sort of currents it can handle, what voltages, and then I'll note it on the label, because it doesn't have current limiting, you know, so that, say I don't use it for a year and then I forget, you know, and I know it's 8 amp supply or whatever, but I can't remember how much voltage I can pull the 8 amps out, right? It'll be on the label. Other thing I wanted to point out, I did not include an output fuse, but what I am going to do is basically do some tests at around in between the 12 to 18 volt region, loaded at about 2 amps, 3 amps, even at 18 volts. Take a current measurement on the line of that, load it at 8 amps at about 12 volts, take a current measurement on the line, and I'll fit a fuse that will blow if this thing's, you know, shorted or overloaded for a few minutes, and that's what it will have. You'll be surprised, that's all that's in most things, so there's nothing wrong with that. This transformer can take quite a lot. It's got quite thick windings. Transistors are beefy, so, you know, if this thing got overloaded for 5 or 10 minutes, it'd probably take it. And I'll design the fuse. I'm not making the fuse. I'm choosing the type and rating a fuse, but I will do that adequately. So that's how I'm going to deal with that. All right, that concludes the video and this build. Other than fitting this. If you like the content, please like and subscribe. If you have any questions, leave them down below, and I'll see you all in the next one. Bye.